All right, we're going to be working in lesson 6.2 today, and it's going to be called substitution, all right? And this is going to be a method that we're going to use to solve a systems of equations. Okay, so let's kind of define what substitution is first. The process of solving a systems of equations that will result in an exact solution. Okay, so now I have already talked about graphing and how graphing, where they cross or whatever will give us an answer. However, it gives you an approximate answer. It doesn't give you exact. It's nice when it's like 2s and 3s and 4s, but what happens if it crosses at 2.4? Well, you're not going to be able to tell that on the grid. Is it 2.4, 2.5, 2.6? So what we need to do is we need to come up with a mathematical way to solve a systems of equations other than graphing, because it's not going to give us exact solution unless we use technology. All right, so substitution is going to be a mathematical approach that's going to give us the exact answer, and that's going to be really important to us. All right, so let's go ahead and come down here. And this is solve using substitution, and we are going to do that here in a minute, but I actually want to review and go ahead and graph and kind of show you how they're related. So we're going to graph first, and on this guy, we're going to solve for y. So we've got to isolate this y right here. So to isolate the y, we need to move that 2 over. So to move the 2 over, we're going to divide by 2. So we get y equals, remember there's a 1 in front there, 1/2 x. So now when we come down here and graph that, since we don't have a b value or y-intercept, we're going to start at 0 and then go up 1 and over 2 and kind of keep that pattern going. So go ahead and get yourself some dots going on your grid there. And then kind of go down the other way, down 1 over 2 to the left. All right, and then once you've got that, go ahead and let's draw a graph or draw your line. Okay. All right, and then let's go up to the other guy here. And we're going to solve for y on this guy. So we're going to subtract the 4x off to the other side there. So we have 2y equals negative 4x plus 10. And then we're going to divide everything by 2. So y equals negative 2x plus 5. So now we're going to go ahead and graph that. So we're going to start at plus 5. And then a negative 2 will be down 1 or down 2, right 1, down 2, right 1, down 2, right 1. All right, like I said, get some points, and then go ahead and let's draw your line in. Okay, so now that we've done this, I know my line wasn't the best here, but we can see where it's probably going to be crossing there, okay? And so we learned that we would call that 2, 1 would be your answer, right? It has one answer because they're crossing. So now what we're going to do is I'm going to show you kind of the same thing, but let's do it with substitution. Now, first thing I'm going to do is I'm just going to kind of draw a wall here, and then I'm going to go ahead and transfer the equations over to this side so that you can kind of compare them. So then we got 4x plus 2y equals 10. All right, so substitution sounds exactly like what it is. Just like you substitute into a basketball game or a football game, etc., you substitute here. You replace something, okay? So when we're looking at this guy, when we substitute, we're going to take whatever you have to have an x equals or y equals. That's not negotiable. There has to be one, and if there's not one, we're going to have to make one. But since we have an x equals here, we're going to substitute. We're going to take the 2y, and we're going to plug it into whatever this guy says right here. So he says, plug it into x. So we're going to have 4, take x out, plug 2y in its place, and then continue to go ahead and copy down the rest of this. So I get a plus 2y equals 10. So now I'm going to go ahead and multiply 4 times 2 and get 8y plus 2y equals 10. Combine like terms. 10y equals 10, and then divide, so y equals 1. Now, that, if I come over here and look, my y value on this side was 1, so that's looking pretty good. We're getting the same thing. That's good. Now, we've got to figure out how the heck do we get this x, though? And so when we're looking for the x, what we're going to do is we're going to take this guy, and we're going to plug him back into one of the two equations. It does not matter which one. Now, obviously, like I always tell you, pick the easier of the two when given the option. So we're going to go ahead and plug y into that first equation. So we're going to have x equals 2 times 1, or x equals 2. So your coordinate point will be 2, 1. So if I come back over here and look at my grid, our coordinate point over here was 2, 1 as well. So this is the graphing form that's usually giving you about what your answer is. This is substitution, which is giving you exactly what your answer is. Okay, all right, let's go ahead and take a look at another problem here. All right, so in the last problem, I told you you have to have an x equals or a y equals. Well, in this case, we have two of them, so we're doing great, okay? So again, we're going to circle one, and we are going to plug it in to whatever this says. So this says plug in for y, so I'm going to plug this in for y. So I'm going to have 3x minus 8 equals, and then I'm just going to copy the rest of this side down, 4 minus x. Now we're going to solve the equation. There's a lot of ways to go about this, but I'm going to go ahead and start by adding x to both sides. If you still need to draw that wall, okay? So I get 4x minus 8 equals 4. Add 8 to both sides. So 4x equals 12. So when you divide, x equals 3. Now again, we got to still come up with the y value. So I'm going to take this, and we can plug it into either one. It doesn't matter. So in this case, I'm just going to plug it into the second one. So I have y equals 4 minus 3, or y equals 1. So my final answer here will be 3, 1. Okay? All right, let's go to the next page. All right, so you remember me talking in the last two problems about you have to have an x equals or a y equals. Well, when I'm looking at this, we have no x equals and no y equals. So that means we've got to make one. So now if I'm looking at all these guys, there's one thing in particular I'm looking for. And that is what has a 1 or a negative 1, but usually it's a 1. What has a 1 out in front? So if I'm looking through here, nope, that's got a 2. Nope, that's got a 7. Nope, that's got a negative 4. But look at this guy right here. He's got a 1 in front. So whatever has a 1 in front, you're going to isolate him. So we're going to add the 1 over to the other side. So x equals negative 4y plus 1. Now, when you do that, cross this guy off because you're not going to use him anymore, all right? You have him. He's just right here now. He just looks a little different, okay? So now again, we're going to take this and we're going to plug it into, it says x equals, so we're plugging it in for the x. So it's going to go right there. So I'm going to have 2. Instead of x, put negative 4y plus 1 plus the 7y equals 3. Okay, now distribute. So negative 8y plus 2 plus 7y equals 3. Go ahead and combine like terms. So let's put together the negative 8 and the 7. And so we're going to end up with negative 1y plus 2 equals 3. Okay, let's go ahead and subtract that 2 off. So negative 1y equals 1. And then divide, so y equals negative 1. Okay, now you're going to take this and you're going to plug it back in up here at the top into one of these. You can plug it in here. You actually can plug it in here, even though we're not really using it anymore. Or you could plug it in here. I recommend right here because I'm going to plug that y in right there, and that's going to be easier than plugging the y in up here and solving. So I'm going to go ahead and take this, and I'm going to plug it in right there. So I get x equals negative 4 times negative 1 plus 1. Or x equals 4 plus 1, so x will equal 5. So your coordinate point will be 5, negative 1. Okay, so let's take a second here and let's write a note out off to the side. Okay. Must have an x equal or a y equals. Okay, if you don't, okay, so if that didn't happen, solve for the variable that has a coefficient of 1, okay? Now, guys, coefficient here, that's just a fancy word for number out front. Number in front of letter, if you didn't know that, okay? If you knew that, fabulous. If not, though, that's what that means, okay? Number in front of letter, okay? Oh. Okay, let's go ahead and go down to number 4 here. So on number 4, again, we're looking for something with a 1, technically a -1, but usually they're going to be 1s for us. Okay, so if I'm kind of looking through here, this guy right here, I'm going to isolate that y right there because he has a 1 in front. So to isolate him, I'm going to add the 3x over to the other side and get y equals 3x plus 2. Now, once you do that, again, cross him out. We're going to take 3x plus 2, and we're going to plug it in for the y up here at top because it says y equals, it goes in for the y. So we're going to take him and plug him right there. So I've got 6x minus 2 times 3x plus 2 equals -4. So again, I have everything the same except for the 3x plus 2, replace that y. Okay, so let's go ahead and now distribute the -2 through. So I've got 6x minus 6x, -4 times 2 is -2 times 2 is -4, equals -4. So now I combine like terms here, and those cancel out. So my answer is -4 equals -4. So when you get something like that where it's exactly the same on both sides, that's going to be your infinitely many solutions, or IMS. Okay? All right, as kind of a side note though, what would happen if we would get like -4 equals 8? Well, that doesn't work so well, so that would be where your no solutions would come into play. Okay? All right, that concludes the notes for lesson 6-2.